All right. So, for example, a software that represents like a shop, right? And the shop can provide services to sell merchandise, for customer support, and process complaints, right? So, interestingly, a customer, shop customer, well, they can essentially use all of these use cases, but there is also a vendor who can participate here, and there's also a boss or some sort of manager that can participate in processing complaints. Does this really describe what the software does and what exactly happens inside those bubbles? No, but I have pretty good idea what you're trying to tell me, what the software is going to be all about. Again, this puts me right on track, so I don't have to theorize about what's what, but this really puts me on track in terms of understanding what you're trying to tell me, right? And I can now read your functional spec and go back to this diagram, read it again, and move on. Now, with use case documentation, this is a use case diagram with the use, and we introduce them really informally because I want to kind of intuitively realize that actors are outside of our system. Inside the box is what's inside of our system, and we have those use cases available, and so particular actors somehow can do those things to the system, right? So, and I was just saying that inside this bubble, each use case formally then by the time the functional specification is complete, the use cases will describe in detail the steps that takes place, preconditions and post conditions. So again, this was in that handout that was demonstrating that virtual game environment that we had a few weeks ago, right? But at least at this level, that's what I want you to think about and include in your functional specification when you submit it. An interesting observation. The use case diagram, of course, is very simple. It is not capable of providing us any structure, information about any classes or relationship of software classes. It doesn't tell you exactly any dynamics that take place at runtime. It doesn't tell us what kind of user interface we're using, right? Because there could be a database, actor which doesn't have any user interface. It's just network connection and exchange of data over that network connection. There's no user interface. It's all background processing, right? But even with the user, we don't specify, like on that previous example with the time management, right? So this time management for hourly, salary, and commission could be through a time card, right? The card reader, time card reader, so that it just everybody has to swipe their card on the way in and out of the building or something like that. So the use case diagram really doesn't tell us about anything about the user interface. So many things that are not specifically given right away to us by use case diagram, and yet still it's very useful. It's very useful to have it in our functional spec because they give us a highest view of what? A view of what system can do and who are the actors that trying to achieve those goals, right? So each use case, why do these actors even bother working with our system? Well, because they have some goal in mind. But perhaps each actor has their own goal, but the system also has their own set of goals. So when we describe what each bubble does, we're describing that as well. What is achieved? What is the result of someone selling the merchandise, right? Or buying the merchandise, depending on what the particular language is. So anyway, and examples of that would be, again, a credit card could be used, a cash could be used, and there could be, records made in a database, and a receipt can be generated electronically or printed, and all that is described. And then someone could say, oh, now it's time to think about the structure. What classes do we need? What methods do we need to implement to be able to accomplish this task? So this is the the view of the use case at this level. Other examples of the diagram, of course, is that as we begin to analyze the software, and this is the next stage. So beyond the functional requirements, the next stage is that I will be asking you in the semester project, could you provide a design document, basically telling us something about the set of classes, and what classes would you like to use, and what relationship between those classes would you like to use. So tell us about the structure. What do you think about the structure? How would you like to design your system? Sometimes your project can be so complex that it's impossible to show everything on one diagram. In that case, that's okay. For the semester project, you can just select a set of particular component of the system, right? A subsystem, and show a little bit of design of that part. So some examples. This is kind of like a simple design, but demonstrates the relationships. For example, when you see those dark rhombus marks on the relationships, well, first of all, what can we say about this particular diagram? Well, obviously we can start with the car. So the car is like a centric diagram. This is a car composition diagram. So the car has 4 wheels, 5 seat belts, 2 windshields, and 1 steering wheel. Okay, but interestingly, when you see those dark filled rhombus shapes on the side of on a particular side, what it says here, it says that a car would be invalid software object if it doesn't have a steering wheel, or if it doesn't have 4 wheels or 5 seat belts or 2 windshields. Essentially, if you take away one of these, the entire subsystem that we're trying to show here becomes invalid, right? So essentially, the car will exist only if all of these components also exist around the car, and they're usable in some way. So that's what this composition relationship demonstrates. So sometimes the relationships are strengthened by introducing this composition relationship. So because if there's no composition, let's take a look at, we already looked at the inheritance diagram. We'll talk a little bit more about inheritance in the future. So here's a good one to think about. So what's involved? The structure, right? So the structure here is that we have some classes: a person, a dog, a house, and a room. All right, so interestingly, house apparently also has, see this aggregation, composition of rooms, and there's this multiplicity asterisk is present on this association, which is a composition, basically telling us that the house would be invalid without some rooms. So the rooms must be present, right? Then we can say, okay, we have a functional house in this application. Then we say that the person has the house. So apparently, house has no knowledge about the person. So the house has no knowledge about the person. However, a person keeps track of the house. So apparently, the person class has a reference field which points to a house. Now, because there is no aggregation on this particular association, it is probably okay to create a person class and keep the house reference null or unassigned. There's also, it tells us that if there's a dog, right? So a person can have any number of dogs, right? From 0 to apparently any number of dogs here. And the dog, each dog, if the dog will exist, will also have a reference to the owner of that dog. So by design, I'm just looking at the diagram and I can tell the story because that's what the diagram tells me, right? So class diagrams tell us what the structure is. And when you try to interpret it, it tells us what's possible and what's not possible. So for instance, if I want to implement a method that says walk the dog or something like that, and the method receives dog as an argument, as a method parameter, then I already know that I also have the access to the owner. Because if you give me the dog, it will also have an owner of that dog. So to be able to walk the dog, I may do things to the person who owns the dog as well. This is what the class diagram tells me.